Move towards the fifth technical session of the Faculty Development Program. It is a matter of great honor and privilege to welcome our distinguished expert, Dr. Dilip Sharma, Professor HAG in the Department of Mechanical Engineering at MNIT, Jaipur, and currently serving as Dean International and Alumni Affairs. Dr. Sharma is a renowned academician and researcher with more than 3 decades of teaching, research, and administrative experience. He has guided 16 PhD and 49 MTech scholars, published over 160 research papers, authored 17 books, and holds 8 patents, out of which 6 are awarded. His research contributes span across biodiesel fuels, IC engines, emissions, alternative fuels, and renewable energy systems. With his vast experience in academic, industry consultancy, and national level committees like AICT, NBA, NAC, UPSC, and DRDO, today's session is expected to be highly insightful and enriching for all participants. We are truly grateful to have you with us, sir. With great respect, I invite Dr. Dilip Sharma to begin the fifth session of Faculty Development Program. Thank you, sir.
Yeah, thank you very much for a generous introduction. Good evening, everyone. Am I audible to all of you?
Yes, sir.
All right. So I'd like to share my screen. Just let me know whether the presentation is visible to all of you.
Yes, sir.
I think, all right. So what I would do is I'll minimize this so that... yeah. So as stated that today's topic is hydrogen fueling in IC engines. So I'll be talking about hydrogen fueling. But before switching directly to the hydrogen fueling, I'd like you people to have a feel of what fuel meant for us. You know, long back, if you talk about the energy demand of a primitive man, that is 10 to the power 6 years ago, that was hardly 2000 kilocalorie per day per person, and that to meet out its fooding requirement. And we all know we started producing energy by first of all burning wood, and then we switched to coal and so on. Over the past century and a half, we were using liquid fuels, and now we are shifting towards the gaseous fuels. The nature has taught us that we need to shift from solid fuel to liquid fuel, and from liquid fuels to gaseous fuels. And it is very interesting is to notice that solid fuels, they burn, but burn with a much lesser efficiency as compared to the liquid fuels. And similarly, the gaseous fuel, they burn much better than the liquid fuels. So by the nature also, we have evolved from solid fuels to liquid fuels and liquid fuels to gaseous fuels. You can see in terms of, you talk about automobile also, we had previously engines being operated by steam, and those were operated by coal. Then we switched to liquid fuels like petrol and diesel and so on. And nowadays we are switching to gaseous fuels, so-called CNG, LPG, and so on. And future is going towards a hydrogen economy. There is another interesting slide which indicates that our future fuel is going to be hydrogen. If you look at this slide, what you see is in the wood, the hydrogen by carbon percentage is of the order of 0.1. In coal, it is of the order of 1. Almost all the liquid fuels, they have H by C in a range of 2. And then we switch to the gaseous fuel. We will talk about methane. It is CH4 and so on. So what is observed by this slide is that the trend is indicating that over the period, while we have shifted from solid to liquid, liquid to gaseous fuels, the hydrogen by carbon percentage in the fuel has also changed, and changed to extent that H/C percentage has increased. So in the recent fuels, what is happening, that the hydrogen percentage is increasing over the years and the percentage of carbon in the fuel is decreasing. And if we extrapolate this, we can say the future fuel would be having a fuel in which hydrogen by carbon percentage would be infinite, which means we'll not be having any carbon in the fuel, and that fuel would be hydrogen. So the trends are also indicating that the hydrogen is going to be the future fuel for us. As I've mentioned, if you wish, I can be bilingual also. If, wherever you people feel like, you can just interrupt me, and then I'll switch over to Hindi as well. Gaseous fuels, why they are better than the liquid fuels? Because you can get a thorough and homogeneous mixing with the air. So when you have a homogeneous mixing of air and fuel, that will result in improved combustion, improved flame propagation rates because of homogeneous mixing, delay in the onset of combustion irregularities, and extended the lean burn limit operations. So all these parameters, they result in higher engine efficiency and increased power output. So that's why we are shifting towards the gaseous fuels. Talking about hydrogen fueled automobiles or hydrogen economy, this cannot be directly switched from the conventional fossil fuels to a hydrogen. We have to do it in stages, and the government has a policy which I'll be indicating in the next slides. So what we have with us is the simplified way of switching towards hydrogen is using hydrogen in internal combustion engines. Then we will be going for hydrogen-based hybrid vehicles, and then hydrogen fuel cell. Directly, we cannot jump because of several factors. So we'll be discussing this in more details in the coming slides. What is hydrogen? If you talk about hydrogen, it is, we know, the first element in the periodic table. It's got one proton and one electron. It's a diatomic molecule, we all know. And the interesting thing is the next point. This fuel has got highest energy density or highest energy content on mass basis, so per unit mass, that is on kg basis. This fuel has got 2.6 times the energy as compared to gasoline. But on volume basis, it's got the lowest energy density. So per meter cube, if you talk in terms of meter cube of hydrogen, it's got 1/5 of the gasoline. So on volume basis, this fuel has got lowest energy density, that is 1/5 of the gasoline. And on mass basis, it's got the highest energy density, that is 2.6 times than that of the gasoline, or what we call is petrol. Hydrogen abundantly available in combined with carbon or oxygen, and examples are methane and water and so on. So all organic matters, you'll find carbon. So carbon is abundantly available. Hydrogen is not found in abundance in a pure state, but it's always found in a bound state with carbon or oxygen. It's the most abundant element available in the universe. It's gas under the standard conditions. It liquefies at minus 253 degrees centigrade. Another interesting thing, it's odorless, it's colorless, it's non-toxic and non-carcinogenic. So that means if there is a leakage of hydrogen, you'll not be able to see to it, you'll not be able to smell it. And that's why the hydrogen cylinders which are being supplied nowadays, intentionally, we add odorant and colorant in them. Hydrogen burns very fast, so it's a highly flammable gas. Since there is no carbon available in the fuel, so it will not produce carbon monoxide, carbon dioxide, or particulate matter in that. Because it's not having any carbon, the flames are not visible because it will burn without a flame. Now, when it burns in an internal combustion engine, because of higher temperatures, it reacts with the nitrogen available in the nature, and it produces NOx. So it's the only emission which hydrogen-fueled engines would produce, that is NOx emission. And we can call it as an energy carrier, not as a fuel. Why should we go for hydrogen? As you all know, petroleum reserves are being depleted, and the prices are susceptible to foreign events. If you talk about biofuels, including ethanols, they cannot meet out our growing demand. So hydrogen is a fuel forever. Hydrogen cannot be depleted. Hydrogen has the ability to make societies completely energy independent. And when you mix hydrogen with a natural gas, it is called hang. Hydrogen is the perfect fuel to run the fuel cell because its pure form of hydrogen reacts only with the oxygen in the fuel cell and produces water. You all know that hydrogen fuel cells are quite common, and we have heard a lot about them. So a lot of research is going on hydrogen-based fuel cells, and the end product of a hydrogen fuel cell is water and electricity. Hydrogen burns more efficiently and creates energy more efficiently than the gasoline, as I've told you. It's non-toxic, environmental friendly. So these are attractions. Attractions are further, if we say it can be produced locally, it can be considered as a renewable energy source. It's got high energy density on mass basis, and it's complementary to the matches of electricity as well. And of course, it's environmental friendly. When you talk about carbon-free energy, a sunlight that hits the earth for 1 hour is equal to planet's power requirement for one complete year, and that is equivalent to 1.3 trillion barrels of oil from the sun. How to capture it? We can use solar cells. These solar cells could act as a source of hydrogen production. So what can be done is we can use a solar cell to produce electricity, to disintegrate water into hydrogen and oxygen, store them in a different place, and then you can transport hydrogen. And that's the simplest way of producing hydrogen. If you look at the supply and demand of hydrogen, you can produce hydrogen from coal, natural gas, biomass, solar thermal, through renewable energy systems involving solar photovoltaic, hydrogen, wind, nuclear electric methods, and nuclear heat. And the areas where we can use this hydrogen is internal combustion engines, in fuel cells, where in fuel cells you can use it in fuel cell driven engines. Commercially, you can use it in fuel cells for other application, for residential application, wherein you use the fuel cell developed energy to heat as well as to electrify the buildings, and the tertiary application, generation, and so on. And of course, we all know hydrogen is used in rubber industries as well as. So hydrogen got vast use. Now, I have talked a lot about the qualities and benefits of hydrogen and why till now we haven't used it. क्यों नहीं use किया हम लोगों ने? The energy efficiency of the complete hydrogen cycle. That means starting from the method by which we produce the energy, we store the energy, we distribute the energy, and use the energy. So all four things, that cycle is involving a lot of barriers. और उसकी वजह से what is happening is the cost of the life cycle of a hydrogen-based system has increased significantly. People are working in different sections. A lot of groups are working in the direction of production of hydrogen. Other groups of people or researchers working is to store it, to distribute it, and another set of scientists and engineers is working on the use of hydrogen. Fuel cell, again, if we talk about the hydrogen operated fuel cell, the cost of hydrogen operated fuel cells is significantly high, and the reliability and the lifespan is a big challenge. So abhi at present, the cost is significantly high and the lifespan is quite less. And at the same time, fuel cells need a highly purified form of hydrogen if you intend to use it. Third challenge is the efficiency, the safety, reliability of hydrogen storage, and the media for mobile systems. So all these are the factors. Now, coming to some of the major properties related to hydrogen. If you consider 1 unit of a gasoline and you talk in terms of the percentage, assuming in mass basis and volume basis, if we have taken 1 unit of a gasoline, that is petrol, then methanol has 0.44 or 44% of energy on mass basis and 51% of energy on volume basis. Ethanol has 61% and 69%. Methane is 1.1, that is 110% of it, energy content per unit mass, and per unit volume it's 0.29. Hydrogen, as I've said already, has 2.6 times energy on mass basis as compared to the gasoline, and has got 1/5 or 20% of the energy on volume basis. Some physico-chemical properties, I have mentioned it over here, but we will not be using them much, but you can see to it. The heating value on mass basis is 120, lower heating value is 120 megajoule per kg for hydrogen, and for methane it's 48, for petrol it's 42 to 44, so it's clearly 2.6 times than that of that. Flammability, if you see, for a gasoline is 1:8 volume of air, and for hydrogen it is 4.1 to 74. So it's got a wide range of flammability. You can burn extremely lean as well as extremely rich mixtures of hydrogen and air. Explosion limits again is significantly high, 18.2 to 58.9 volume of air, whereas for gasoline it is 1.4 to 3 only. Molecular diffusion, it's 0.6 centimeters square per second as compared to 0.05 centimeters square per second for gasoline. So in case of a leakage, it spreads out and diffuses very fast. So that sometimes make it more inherent and safe. Another property which makes hydrogen fuel as a safe fuel is the auto ignition temperature, that is 571 degrees centigrade as compared to close to 400, 380 to 400 degrees centigrade for gasoline. Liquid density is 77, whereas if you consider for gasoline it's 720 to 780. Yes, there is someone who has raised a hand. Just a minute, let me go back to where we were. If someone has raised hand. Can anybody tell me what was the issue? Someone has raised the hand. Shall I continue? So let's quickly move to other properties, ignition energy, flame speed, and so on. Now, as I have told you, जैसा कि बताया मैंने आप लोगों को, हाइड्रोजन को हम इंटरनल कंबशन इंजन में भी यूज कर सकते हैं, एज ए फ्यूल सेल भी यूज कर सकते हैं. So what are the properties which are favorable to using it as a fuel in internal combustion engine? First favorable property is a wide range of flammability. So you can burn extremely lean air fuel mixtures where you don't want the engine to give you extra power, but keep on the engine running. And you can go to a very rich air fuel mixture wherein you would like to produce significant amount of energy. तो एक ही हम बहुत बड़ी रेंज के अंदर हाइड्रोजन को ऑपरेट कर सकते हैं. So from the same size of engine, you can produce large amount of energy. Low ignition energy. So to start the combustion, unlike in spark ignition engines, you require a very little amount of energy to initiate. So you don't require big spark plugs, etc. Even a small source of heat can initiate the combustion. Small quenching distances. High auto ignition temperature makes it inherently safe. High flame speed at stoichiometric ratios. So it means that the combustion is completed very fast. So you can produce more energy. Highly diffusible and very low energy density on volume basis. Now, if you're storing hydrogen, the energy content to store same amount of energy, you require 9.5 kgs of hydrogen to have energy equivalent to 25 kgs of petrol. Now, in order to store 9.5 kgs of hydrogen, you require a tank, because you have to store it at a high pressure, that weighs 55 kgs. Whereas to store 25 kgs of petrol, the tank will weigh only 17 kgs. So that is a main challenge, storing of the hydrogen. And typically the fuel, if it is in a gaseous state, it takes 4 times the space in terms of a volume of petrol to produce same amount of energy. If we pressurize it, the volume requirements tend to decrease, as I've shown it over here. Ignition limits, as again I have already mentioned, कि बहुत ज्यादा एयर फ्यूल रेशियो के रेंज के अंदर काम कर सकते हो कंपेयर टू अदर फ्यूल्स. Lean flammability limits are very large in that, 4 to 0.1, as you can see, compared to methane, propane, butane, and so on. Air requirements, in order to continue the combustion, you require very little amount of air. You can do de-throttling also to get the benefit of lower volume of fuel being burned under idling conditions. Ignition energy, मैं already आप लोगों को बता चुका हूँ. These curves are just indicative of how much energy is required. So, in order to initiate the combustion in a hydrogen, you require very little amount of hydrogen as compared to methane energy. NOx is again a challenge in this, because, as I've told you, hydrogen burns very rapidly. So, if it is burning very rapidly, there will be a sudden pressure rise once the combustion gets initiated. So that needs to be controlled, and you need to design a combustion chamber which can handle the knocking. High flame speed, hydrogen burns 9 times faster than gasoline and 14 times faster than diesel. So it burns very rapid. So when it burns very rapid, it is at times advantages also. कभी कभी हमको उसके high flame speed का फायदा भी होता है, that we will be seeing in the coming slides. High flame speed of hydrogen causes crank angle duration combustion to be reduced by several degrees, because you don't require the spark to be much advanced. You need to retard it. Other issues, because the energy required to start the combustion is much less, so spark plug का gap कम कर देंगे. Deterioration of lubricating oil, because hydrogen is the lightest element, so it can leak out between the walls of the piston ring and the cylinder and go and mix up with the lubricating oil. So lubricating oil का dilution भी कर सकता है. Similarly, as I've said, it's got a very high affinity of oxygen. It can operate on a wide range of oxygen. So the oxygen sensors engines में लगाए होते हैं, you require those sensors to be highly sensitive and highly calibrated. बहुत accurate O2 sensors are required. The advantage of lean mixtures to operate at low load conditions is always good. The disadvantage of increased hydrogen concentration is in the exhaust gas and idling. So on. फायदे, since no carbon, you'll not be finding any carbon monoxide, carbon dioxide, particulate matter, because there is no carbon in it. If at all some carbon is coming, that could be because of mixing of the lubricating oil, and that is going out from the combustion chamber. Any amount of these pollutants are because of the lubricating oil coming out. NOx emissions are high, so we need to take care of that only. So you can see from this curve, if you see the close to air stoichiometric air fuel ratio, the NOx emissions जो आपके हाइड्रोजन से आ रहे हैं, those are significantly high as compared to natural gas and other gasoline. Now, these are few interesting slides. वो कुछ physico-chemical properties मैंने बताई थी. Probably many of you might not be having much interest in that, but these slides, what are the safety issues of hydrogen? Hydrogen being the smallest and the lightest element in nature, it diffuses rapidly to the surrounding to a non-combustible proportion, and as you all know, it diffuses 3 to 8 times faster than air. तो क्या हुआ, अगर कहीं लीक हुई, so it spreads and diffuses into the atmosphere very fast, much faster than the gasoline. So when it diffuses fast, the probability or chances of catching fire is less. You might have heard, or might have seen in TV, a lot of times the LPG companies, they give an advertisement कि अगर gas leak होती है, तो what you need to do is you need to open up your windows from the kitchen and stop the chula so that the whatever gas which has leaked out can diffuse out. So this diffusion is even much more higher than the LPG in hydrogen. So it diffuses out very fast, forming a non-combustible mixture, and which can make it inherently safe. Hydrogen fires burn very rapid and radiate very little heat, thus are relatively short-lived. This is again another important. जैसा कि मैंने आपको बताया कि हाइड्रोजन जो गैस है, वो उसमें कार्बन होता नहीं है. It doesn't have any color, it doesn't have any odor. So when it burns, you will not see the flame. इसकी फ्लेम दिखाई नहीं देगी बिकॉज कार्बन है ही नहीं इसके अंदर. फ्लेम्स आर बिकॉज ऑफ द कार्बन. सो यू विल नॉट बी सीइंग द फ्लेम्स. एज ए रिजल्ट, एंड इट बर्न्स वेरी रैपिडली. तो क्या हुआ, आग लगी और आग बुझ गई. The hydrogen which has been supplied, as I again told you previously, that hydrogen which is being supplied is intentionally being added with adorant and colorant, so that in case if there is any fire or a leakage, you can identify it. So hydrogen cylinders and hydrogen being supplied are being provided with adorant and colorant. Hydrogens are safer than gasoline tanks unless continuous supply of heat is been there. Even a leak from the hydrogen tank would be self-limiting. It is odorless, so you need to add an odorant. It is invisible, you need to add a colorant. Hydrogen fire burns very rapidly. A person can be close to a hydrogen fire and can be burned without seeing a flame. It requires a little energy compared to the methane and gasoline, thus weak ignition sources can burn. So all these factors are interestingly available. I've just kept a screenshot from a video available comparing two different cars. One was designed to operate on a gasoline and another was hydrogen. So if you see the upper left photo, the two cars are there. The front car on the upper left was a petrol driven car, and the rear car on the upper left front was a hydrogen based car, and intentionally both the cars were put on fire at the same time, and after 100 seconds it was observed that the car which had a gasoline tank totally burned and fully got burnt out, whereas the car which was having a hydrogen cylinder, it burned very fast initially, the flame, and then the fire got extinguished. So the damage caused to the car was significantly much more, which was having a gasoline tank as compared to a hydrogen tank. So this clearly indicates that even if there is a fire of a gas on a hydrogen car, it would be relatively safe, and the entire vehicle will not burn as compared to that of the gasoline based vehicle. So because of highly diffusible nature, high combustion speeds, this makes this fuel inherently safe. People have done a lot of other tests also, and H2 escapes faster 10 minutes to open fire burn. So these issues have been resolved. Now, हाइड्रोजन को हम कैसे यूज करें in a vehicle? We can use hydrogen and petrol mixture in a dual fuel mode. What do? Is we supply gasoline and a hydrogen. Gasoline, of course, if it is a carbureted system, you can supply through a carburetor. So both gasoline and hydrogen can be continuously supplied through the inlet manifold, which you will be seeing in the coming slides, and we can use it. Another method is in a dual fuel mode, you can use either port or direct injection of a hydrogen in a diesel engine, HCNG or high-thane, and hydrogen in pure in a port injection, and hybrid vehicles using hydrogen, and the last one is in the fuel cell. ये सारी different techniques which I have already mentioned cannot be adopted and are not being adopted directly in present scenario. What government has decided, they have set up a National Hydrogen Energy Board under Ministry of Energy Sources, that is MNE, we can NHEB बनाया है इन्होंने, and NHEB, they define that you need to have near-term goals, medium-term goals, and long-term goals of using hydrogen in automobile. So in the near-term goal, it is decided to use hydrogen plus CNG in internal combustion engines. In medium term, we'll be switching from hydrogen and CNG to pure hydrogen in internal combustion engine. In a long-term goal, we can think of using pure hydrogen in fuel cell. Now, why it's been done? Because making people to understand and adopt the technology very quickly is not that easy. तो लोगों को पहले आपको comfortable करना होता है. You need to make them feel comfortable of using hydrogen. I don't know how many of you know it. The CNG which is being provided nowadays is not pure CNG. It's not methane pure. It is a mixture of hydrogen and CNG, and that is being provided to allow the people to have a first-hand experience of how hydrogen can be used in internal combustion engines in automobiles. In later stages, in the medium term, we will be switching to pure hydrogen tanks, wherein we will not be using CNG tanks but hydrogen tanks, and hydrogen would be purely supplied to the internal combustion engine. And long term, we will be switching over to use of hydrogen in a fuel cell, not in an internal combustion engine. Project का overview क्या कहता है? Near term, what we can do is we can use hydrogen or rather CNG tanks, wherein we will be mixing hydrogen in CNG and using it. Percentage of mixing of hydrogen can be from 20 to 30%, but nowadays we are having only 8% hydrogen blending in the CNG. The vehicles operated are buses, cars, and three-wheelers. Medium term, what we will be using compressed hydrogen or metal hydride based tanks, wherein we can store hydrogen, and this pure hydrogen would be supplied to the internal combustion engine to produce heat. लॉन्ग टर्म ड्यूरेशन की बात करेंगे तो लॉन्ग टर्म में हम लिक्विड हाइड्रोजन को या मेथनॉल टैंक्स को यूज करेंगे, एंड वेयर वी विल बी यूजिंग इट इन अ फ्यूल सेल फॉर अ हाइब्रिड व्हीकल्स एंड सो ऑन. नाउ सबसे पहले जो मैंने आप लोगों को बात किया कि हाइड्रोजन को नियर टर्म में लोगों के को कॉन्फिडेंस बिल्डिंग के लिए यूज करने के लिए कैसे किया जाए. So government straight away decided nothing doing. We will not be modifying the engine, we will not be modifying the vehicle. We'll be using the same vehicle, but we'll be adding some percentage of hydrogen in the CNG driven vehicle. And even people might not be knowing it, that significant percentage of hydrogen is there in the CNG which they are using. So uska result kya hoga? People will be confident, अरे हम hydrogen use करते आ रहे हैं, so will not be any thing which is dangerous for us. So it allows the use of existing technology and existing methods for operating the system. Because we are using CNG, so NOx emissions would be less, because इसमें methane की percentage ज़्यादा है, so 5 to 30% हम hydrogen add कर सकते हैं, and it provides an experience in a safe handling of hydrogen, making people confident about using hydrogen. Now कितना percent blend करते हैं? These are two different names. There are two or more different names of using hydrogen and CNG mixtures को जो करते हैं. One is called HANG, hydrogen added natural gas. Various percentage, HANG के अंदर various percentage could be there from 8 to 50%, whereas high-thane is a standard trade name given to a blend of hydrogen and CNG, wherein 20% of hydrogen and 80% of CNG is mixed by volume. So Hythane has a fixed percentage of hydrogen, and this is the registered trademark of Hydrogen Consultant Incorporation in USA. So we cannot say a mixture of hydrogen and CNG as a Hythane unless we have 20% hydrogen and 80% CNG by volume in that. But hang is a generalized term, so we can use hang or HCNG, wherein in hand we can have 8 to 50%, and presently we are using 8%. Uh, uh, for safety, we do not normally go beyond 10% in our country. So we have already met out the requirements of a near term because CNG filling stations already exist करते हैं, CNG driven vehicles exist करते हैं, हम लोगों को ज्यादा changes करने की जरूरत नहीं है. So we have already adopted use of hydrogen in internal combustion engines in the form of CNG driven vehicles. इसका फायदा क्या होता है? Its supplementation of hydrogen into a natural gas extends the lean burn limits, lowers the peak combustion temperatures, it dramatically reduces carbon monoxide and NOx emissions. Low risk and nearly commercial technologies start using hydrogen, allows the government agencies to promote use of hydrogen at a lower cost, can take advantage of existing investment in natural gas infrastructure, and हम लोग बाग 100% हाइड्रोजन बेस्ड व्हीकल्स की तरफ आगे जाके स्विच कर सकते हैं. This is a simple HCNG genset available at IIT Delhi. We had HCNG dispensing stations long back in 2005 by Indian Oil Corporation. Now, medium term की बात जब बात करेंगे, now we are talking about using pure hydrogen instead of using a methane and hydrogen or CNG and hydrogen. इसके बेनिफिट्स क्या होते हैं कि हमारा कार्बन मोनोऑक्साइड, कार्बन डाइऑक्साइड एंड अनबर्न्ड हाइड्रोकार्बन इमिशंस 100% एलिमिनेट हो गए एज कंपेयर टू HCNG. नॉक्स इमिशंस बड़े हुए होते हैं, but we can reduce it by adopting different technologies, by using EGR, etc. Broad biasing of the fuel source, biomass, natural gas, and renewable energy, etc. It enables setting up of H2 energy infrastructure to reduce dependency on fossil fuels. Hydrogen or internal combustion engine. Issues are complete control of combustion processes still yet to be achieved. Increase resistance to backfire. Backfire is a big challenge in hydrogen. For direct injection of hydrogen, electronic management system ECM is required. Optimization of engine parameters needs to be done. So you need to have entirely new design engine, or you need to optimize the ignition timing, injection timing, and duration for injection and the injection pressure over here. Special focus needs to be taken care on the ignition characteristics. So spark plug का गैप कम करना पड़ेगा, lubricating oil की क्वालिटी को अपन को चेंज करना पड़ेगा, ऑक्सीजन सेंसर्स अच्छी क्वालिटी के चाहिए, and noise reduction के लिए हमको dampers बढ़ाने पड़ेंगे. So these are the issues which have to be taken care when you are using a pure hydrogen as compared to the near term. Near term में हमको कोई changes करने की जरूरत नहीं पड़ी थी. हाइड्रोजन को कैसे इंजेक्ट करेंगे इसके अंदर? You can use hydrogen alone in spark ignition engine. You can use hydrogen plus petrol in spark ignition engine. You can use hydrogen plus diesel in compression ignition engine. You can use hydrogen plus CNG, जो already मैं discuss कर चुका हूँ. The fourth one is already been adopted. Fuel supply करने की कौन कौन सी techniques होती हैं? Carburation is the one. Then you have a continuous manifold injection, timed manifold injection, low pressure direct injection, and high pressure direct injection. इनकी slides मैं आपको और elaborate करूंगा. कंटिन्यूअस कार्बोरेशन में आप कंटिन्यूअसली सप्लाई करते रहते हो कार्बोरेटर की तरह से, और फ्यूल सप्लाई करते हो. तो फ्यूल अपन हाइड्रोजन कहां सप्लाई कर रहे हैं? इनलेट वाल्व से पहले, इनलेट मैनिफोल्ड के अंदर आप कंटिन्यूअसली सप्लाई करते हो, एंड द प्रेशर इज स्लाइटली अबव द एटमॉस्फेरिक प्रेशर, सो दैट ड्यूरिंग सक्शन स्ट्रोक यू सप्लाई हाइड्रोजन. कंटिन्यूअस मैनिफोल्ड इंजेक्शन आप इनलेट मैनिफोल्ड के पोर्ट पे लगा देते हैं, और वो भी स्लाइटली ग्रेटर देन एटमॉस्फेरिक प्रेशर होता है. टाइम्ड मैनिफोल्ड इंजेक्शन, जो आपका इनलेट वाल्व के ऊपर आप इंजेक्टर लगा देते हैं, सिमिलर टू द पेट्रोल बेस्ड व्हीकल्स, जो फ्यूल इंजेक्टर पेट्रोल की गाड़ी में होता है, एंड देन इट इंजेक्ट्स ओनली व्हेन द इनलेट वाल्व इज ओपन. Unlike in previous case, we had to continuously supply. Then another two are the direct injection inside the combustion chamber, low pressure direct injection and high pressure direct injection. लो प्रेशर डायरेक्ट इंजेक्शन हमारा सक्शन स्ट्रोक होने के बाद में जब कंप्रेशन स्ट्रोक स्टार्ट होता है तब हम इंजेक्ट करते हैं, तो प्रेशर हमारा थोड़ा सा ज्यादा होता है 2 to 8 kgf per centimeter square. और हाई प्रेशर डायरेक्ट इंजेक्शन is been done towards the end of the compression stroke, like in a diesel engine. तो हाइड्रोजन कंटिन्यूअस कार्बोरेशन के अंदर अब ये आपने दिखा लिया, कार्बोरेटर लगा दिया एक, उसके अंदर फ्यूल टैंक से आपने हाइड्रोजन कंटिन्यूअसली सप्लाई किया, एंड वी हैव पुट अ फ्लेम ट्रैप so that the hydrogen flame doesn't go back to the fuel tank. And then in this process, what you do, you don't have a direct control. You have to control through the regulating valve. तो इनलेट मैनिफोल्ड में अगर आपने शुरू में ज्यादा हाइड्रोजन दे दी और आपकी एकदम से रिक्वायरमेंट बंद हो गई, so it will take some time for the entire fuel to burn in the inlet manifold. Continuous carburetor, port injection and direct injection inside the injection chamber, जो मैं ऑलरेडी आप लोगों को बता दिया. नाउ डायरेक्ट इंजेक्शन लो प्रेशर भी हो सकता है और हाई प्रेशर भी हो सकता है. दिस इज कंटिन्यूअस कार्बोरेशन, दिस इज पोर्ट इंजेक्शन and direct injection. If you see, in port injection, mixture calorific value is 3.9 megajoules per meter cube. Power output is, if it is assumed 100%. आप हाइड्रोजन के साथ पोर्ट इंजेक्शन की बात करोगे तो 82% ही रह पाएगी. But when you're using a direct injection, it goes 117. So using a hydrogen in a direct injection engine, you can produce more energy. Sequential low pressure multi-point fuel injection is possibility of tune of air fuel mixture. Increased power output, decreased cyclic variation, and time injection also is added to benefit. So these are the advantages and disadvantages. Disadvantage में क्या, low gas energy density, high delivery in short time, durability, and possible leaks are there. One such example of a small engine of 1000 cc using different techniques were discussed, and you can see the fuel is 17 cc, 300 cc for hydrogen, and liquid hydrogen it's 450, and for high pressure it's 420. So like that, to produce the same amount of direct injection efficiency, start of the injection timing, location of inlet valve, number of injection pulses में भी कर सकते हो to make it inherently safe, pressure of injection, and so on. These are advanced stages, so I'll be skipping many of these things. R&D focus किस चीज पे जाता है हमारा? मिक्सचर स्ट्रेंथ रिक्वायरमेंट, बैकफायर, मिक्सचर स्ट्रेंथ, हमको मिक्सचर को किस तरह से उसकी स्ट्रेंथ को आइडेंटिफाई करें और कंट्रोल कर पाए, जो बैकफायर का इशू होता है उसको कैसे कंट्रोल करें, एंड चॉइस ऑफ अप्रोप्रिएट सिस्टम कौन सा लेना चाहिए, एंड एमिशंस को कैसे मीट आउट करें. सो दीज आर द R&D फोकसेस. Back is, so for backfire we can use ultra lean operations, adopting exhaust gas recirculation to avoid backfire, as well as NOx emissions, avoiding hot spots and sharp edges, and water injection inside the combustion chamber. Electronic fuel injection system के कुछ photographs हैं. Admixture of H2 and gasoline. Hydrogen based fuel cell vehicles की बात करेंगे. So fuel cell is what? It produces electricity rather than heat. So it's a power source similar to that of a battery. It requires refueling, not recharging. Heat and water are the only emissions from a hydrogen fuel cell, and can be used to power homes, businesses, vehicles, etc., and small portable devices. सबसे simplest fuel cell की बात हुई है, hydrogen fuel cell. It was developed by Sir William Groove in 1839. Hydrogen reacts with oxygen electrochemically and produces water as emission and heat. So water vapors basically are condensed and you store water over there. The byproduct is only water, and electrical energy is being produced. They have a very high efficiency of 55 to 60%. Then they said different type of fuel cell का structure होता है, and so on. Type of fuel cell, you have PEM, solid polymer applications, and so on. Now, towards the end, I will be just quickly comparing the use of hydrogen in fuel cell and use of hydrogen in internal combustion engine. So if you see at the present scenario, the technology of using hydrogen in internal combustion engine is mature. हम हाइड्रोजन और सीएनजी ब्लेंड तो यूज कर ही रहे हैं, बट ऑल्सो प्योर हाइड्रोजन को भी इंटरनल कंबशन इंजन में हम यूज कर सकते हैं, एंड इट्स एक्सट्रीमली रिलायबल. Fuel cells, though we have a fuel cell driven vehicles produced by many of the automobile manufacturing companies, but still the technology is under development. Series of production can start quickly. Series of production is quite far away. It might be another 10-15 years to significantly see hydrogen fuel cell driven vehicles in our country. Existing production capabilities can be used. अगर आज सीएनजी की बात करते हो तो हमारे सीएनजी फिलिंग स्टेशन हम यूज कर ही रहे हैं, परंतु फ्यूल सेल के लिए हमको एंटायरली नया फ्यूल सेटअप चाहिए, बिकॉज विल नॉट बी यूजिंग gaseous hydrogen. We'll be using liquid hydrogen being stored. So low temperature storage requirements are there. Low temperature, high pressure storage requirements would be there. हाइड्रोजन को इंटरनल कंबशन इंजन में अगर अपन यूज करते हैं, we can use it in existing vehicle design, wherein we have an engine in place of the petrol or a diesel fuel tank. You can switch it to a hydrogen fuel tank, which can store hydrogen gas. But fuel cell driven vehicle के लिए you require entirely a new vehicle design. So entire chassis needs to be rebuilt for that. जैसा कि electric vehicles के लिए the chassis needed to be rebuilt. Lower addition of the system cost is there. Hydrogen fuel cell driven vehicles are expensive. Purity in internal combustion engine matters but doesn't matter much. पर for fuel cell अगर आपका जरा से भी impurity आ गई, so your fuel cell electrode will get spoiled और आपका पूरा fuel cell खराब हो जाएगा. So highly purified form of hydrogen is required in fuel cell, whereas in hydrogen, when you are using it in internal combustion, you don't require it. Due to low cost, it's specially suited for countries, developing countries like India, etc. And developed countries may think of using fuel cell driven vehicles in near future, but again the cost would be significantly high, so people might still not be interested in using much it. So that's all from my side. Now if there are any questions, I would be happy to answer. I don't see any question being asked. One, sir, safety issues for hydrogen gas. You can speak out also. That would be better for me rather than going to the chat box.
Good evening, sir.
Yeah.
Sir, I am also working on the biofuels research center itself, sir. So I was thinking that for using hydrogen gas, we need some safety measures in the vehicles as well as the experimental process also. So in the upcoming days, what are the safety measures generally we need for using it, maybe in light motor vehicles or heavy motor vehicles?
Right. So first of all, you have to see to it, because as I've said, when we are using any fuel, you require devices for storing it properly. Then from storing to the place where you'll be using it in an internal combustion engine, that transportation requires. And then from transporting it, I'm talking about the vehicle itself. So you require a hydrogen fuel storage tank. That tank needs to be connected to the engine. Now, while connecting it to the engine, what we did in our labs, we installed flame trap as well as fire arresters along with NRVs, that is non-return valves. So these things needs to be taken care of, and of course you need to take care of various other parameters to ensure that makes it inherently safe by incorporating I have already shown in the presentation the safety issues. Yes. So what you require Of course, the hydrogen which we are getting is already having a adherent and a colorant being added into it. So if there is a leakage, you can easily find it out. But to prevent it, what is required is from the fuel tank, you need to supply the hydrogen through a NRV and a flame trap, and then you put it to a fire arrestor. What I will do, is my screen still available?
Yes, sir.
All right. So I'll switch to another slide over here, wherein I have to just check out. I'd like to show a presentation of one of my PhD scholars who did his PhD, and I'll be just quickly showing you few of the diagrams. What we did is we developed a hydrogen fueling system where we put a flame arrestor, and here you can see a flame arrestor and a stabilizing tank, which are coupled with a non-return valve into the system. So this is a entire setup wherein we used hydrogen and diesel in a dual fuel mode. What we did is we had a weighing machine and a hydrogen cylinder, which got a pressure regulator. From it, the hydrogen was allowed to pass through
Sir,
a non. Yes.
Sir, the presentation is not visible, sir.
Okay. Just a minute. I thought my presentation was visible. Is it visible now?
Yes, sir.
Okay. I'll quickly move back. We developed a flame arrestor and a stabilizing tank. And then finally, what we did is this is the design of the experimental setup engine. What we did is we used a weighing machine on which hydrogen, because it's a gaseous fuel. So its best way is to measure the fuel supply on mass basis. So we kept the hydrogen cylinder on a weighing machine, which will continuously provide us its weight. Then it was passed to a pressure gauge and a regulator, and from here through a non-return valve to a flame arrestor, another non-return valve to a stabilizing tank, another non-return valve, and from here we have supplied in the inlet manifold of the engine, and air was added in the inlet manifold. So in a diesel engine, what we did, we supplied air and hydrogen mixture into the system, and the diesel was used as a pilot fuel to initiate the combustion. So that was the simplest method of using hydrogen. Here you can see the entire experimental setup: hydrogen fuel tank, weighing machine, a flame arrestor, flame stabilizer, and the emission analyzers and so on. So that was just a flow of the experimental setup which we used at our place. So any other question?
Good evening, sir. First of all, thank you so much for wonderful presentation. Sir, can we use oxy-hydrogen gas in place of hydrogen, sir? And your
So
suggestions on that.
you mean to say instead of using a hydrogen, hydroxy gas,
Yes,
right?
yes, sir. Yes, sir.
Hydroxy gas is already been used at various places. Rather two of my PhD scholars have used hydroxy gas, and it's in a sense very good. And many of the trucks in USA, they are using hydroxy gas as a source because it is an additive. What happens when you're running the engine? You use the electricity produced from the engine to produce hydroxy gas, and the same gas is again fed back to the engine, and that reduces the percentage of the diesel fuel required in the engine or a petroleum required in an engine. So hydroxy gas is very well suited for internal combustion engine. though it's not having that much calorific value, but it is equally applicable, and people are working in this area.
Thank you, sir. Thank you so much.
Right. So, any other question?
Sir, if possible, please share your contact details, sir.
Mike, pardon, what did you want?
Your contact details, sir. Your contact details.
Okay.
If possible.
Wasn't it available in my presentation? Let me check out. I just share my screen. So, Department of Mechanical Engineering, MNIT Jaipur. Email address is dsharma.mac@mnit.ac.in, and phone number, you can note it down, is 9549654497. There's
Thank you,
another
sir.
one
Thank
also.
you.
Right. If there is any other question, I would be happy, or let's call it a day. Yes, are we done?
Thank you so much, sir, for your insightful and valuable session.
Thank you very much.
Tomorrow we will meet for the we will meet for the next session. The session link will be shared. Kindly joining using the same. Thank you so much.